So let's continue with lecture 2, and we're going to start with some Python concepts. So let's imagine that I made a Python file called myapp.py, which is what we call Python files. And I had a bunch of stuff in that Python file. And so you'll notice as an aside, I have an underscore between my and app, the two words here. And there are a number of conventions. I'm going to try my very best to follow PEP 8, which is a series of great simple rules to follow for naming and organizing your code. There are lots of others, including ones by Google and other major companies, as well as ones that are more popular for various languages. And it's with those especially that I get confused, and so you'll see some of my code and my variable names a little bit sloppy. Again, I'm just pointing that out as something that I'm personally working on. We see here an import for datetime, which is a library built into Python. We're going to have a bunch of different imports for all sorts of different modules that we'll be using within our code. So just library imports are at the top of our file. And above a lot of our objects are going to be any free-floating functions. So just functions that are out on them, out by themselves. A function is just, think of it like a magic spell. It just does a bunch of actions, does some cool stuff, and it can take a parameter. So like if I said shoot a lightning bolt, I could say shoot a lightning bolt like really far or at this place. So whatever you I'm using lightning bolt like a spell in case you didn't pick that up. And so what you would do here is you would lay out the details that you want the commands that you want your code to follow, and it will all be executed once you call or activate this function. And it won't do anything until some function has been called or activated. So that's why I used the term like a spell, because you can kind of sort of write that down. If you're a nerd like me, know these kinds of things. We also have classes, and classes have methods. It's the same term for a function. It's just if a function belongs to an object, then we all call it a method instead of a function. Um, it's a little bit confusing and muddled in Python because this module has its own sort of identification, and you can call it as if it's a class. So you can say myapp.someFunction. So even though this is free floating out, not inside of a class, which Java users would be so offended by, you can it sort of does still belong to a module, a file context that you can reference it like this. And this is dot notation. If this doesn't ring a bell, then you're again study. But dot notation is just saying, hey, look at this file, and then within that file, so it's just like your address, but you would start at USA first, and then your state, and then your town, or wherever you're from. My app, it would be some object. We would also do that, and if I had a method inside, if let's say I put some function inside here, it would be dot some function. So I would do one step further in calling one object to call another object to call another object, which happens to be a function. Okay, so this inside here is represents inheritance, and that's saying when you put something inside in Python, you declare a class and then have parentheses and you have another thing. That means that this object is going to take all of the rules from this object and build on that. In Python, everything inherits from object. So everything starts from object, except for object itself. Object itself, I believe, inherits from null or nothing. So it's the nothing start from nothing. There is something, which is an object, and then from that, everything else. Okay, yeah. When I create an object, Let's say I wanted to have whatever I made, like a user or a player or whatever thing or game or whatever you're trying to code. Um, if I created an object, I would store it in some variable potentially. Um, and then from once I created that instance of that variable or that copy of that variable, then I can have it cast its spells or do its actions by using this dot notation and calling that method that's hidden. You can't see right here. Um, and it can also take parameters. Um, and so I could, so if let's say cast a lightning bolt at this person, I can call a function and pass it a parameter. Um, Now I should mention Python works a little bit funny, and it's cool that as you learn Python, you learn more about other languages as well. And what I've always found very interesting was how Python uses this term self. Um, and what's happening here is that it's every instance method. So every method, for example, if I was programming um, the class human and I was programming a blink method, um, it would have self in here because whose eyes are you blinking? You're not blinking all human eyes. You're just blinking your own eyes. And so the command, because it refers to that example or that instance of a human, has self built into it. So, so even when I cast this spell or I call this method, um, and it looks like I'm not passing it any parameters inside the parentheses here, technically I am passing it this as a parameter. Um, and what you can do is you could, if you wanted to in Python, which is pretty neat, you can write some object dot let's say hidden method, and then pass it some variable, the instance, and then the any other parameter that you needed. I'm pretty sure it's some syntax like that. But what it means is that when you call an object and make it cast its spell, you are also when you run this method, you're also including in that information which human, which self, which object instance is doing that action. So that's built in, kind of cool. And you might be asking, why do they do that? Why is database architecture organized like this, and what's going on? Why did they make these decisions? That's if you want to know that, you've got to do additional reading. So this is there's a Python cookbook happens to be the one that I'm working on, and every little bit is always it's a pretty practical guide, but they show a lot of nuances in how one thing works. So I'm getting a really broader appreciation for what Python can do and how it works. And a lot of these books allow you to get in the minds of the people that created this language and see what kind of problems they were solving. And that gives you such a better appreciation of what you can do with the language and how it works. And so books, this type of book, I find it great. And there's one in this Amazon listing that's below here that Python automate the boring stuff, which is so cool. But it's all really practical stuff. You can learn from about the language, and it's easier to read more often. But these O'Reilly books, I find, provide a really rich and in-depth knowledge to as to why things work the way they do. And you've gotta get a little bit hardcore with this study if you want to um, play at a very strong level. Now let's talk about how we write down our information. How do we store the data? And this is one of the coolest areas of computer science that I've been learning about, and it is I'm just scratching the surface. and it is so exciting. And because the way they've had to organize information and the different types of practices are all pretty neat. And immensely powerful as you learn how to use them. So imagine we have three different classes here. We'll have a user class, and the user class will have some properties like what the user's email address is, what their first name is, last name is. And there's going to be a bunch of others, but this is just for an example. And the user might also have different methods or different actions they can run, like send an email or something. These are just made up. Or save a game if this is a game, or join a group if it's like a social media. And there may probably be a parameter in here saying which group you're trying to join. But anyway, so it's got some methods that a user model would contain. And in addition, the model of a user will also include what other models are connected to this one. So if I did join a group, maybe over here I would have a group object, and I would give it all sorts of properties and rules, and it would also have a relationship category, and that would one of its relationship would be a users relationship, and the users is plural because many different users could be a part of a group, just like how groups is plural. So this is a many-to-many relationship. So many different users could be inside many different groups. Anyway, so that's a many-to-many relationship, and we're going to learn about these types of relationships. And we need to know the type of relationship that you want to connect in your app, because as we build SQL Alchemy, as we build these models, these database schema, this sort of pattern that you want every user, the table of information to have all of these fields, and for this object in your app to be able to do these things, we'll need to learn about SQL Alchemy in order to do that. And SQL Alchemy is our ORM. It's what takes our Python code and will store it into the database for us. And like many other ORMs and many other ways we organize data, they might require us to use an association table, which is an interesting way to resolve a problem that you'll come across, wherein that you might have, for example, many different roles on your website, like an administrator, a subscriber, whatever, and a writer, someone that has partial privileges here but not there. That might apply to many different users, and you'll want to record, you know, every relationship a user has. And so you might have a separate table that says okay, an admin is this user, Jimmy, and a subscriber is this user, also Jimmy. So he will have two different roles, or maybe more. And so an association table is one of the many different solutions that we'll look at about how to manage the organization of our data. Okay, did I get everything? All right, an EM diagram. This is sort of this is a terrible example of UML, the Universal Modeling Language, but it at least is an example of how we can draw out all of our entities and how they would manage those relationships. And so, yeah, wait a second. I just had to Google that. It's not an EM diagram. It's an ER diagram, entity relational diagram. It's entity relationship model. It's how we will connect all of these objects. And so this is a bit of a mix of a UML and an ER diagram. Okay. Oh, last thing, migration. A table doesn't actually change columns. You can't just add in a new column if you wanted to create this. You would have to totally nuke the table. It unless you're using a migration tool that will help you carefully migrate your data and modify that table. So that's a migration.